Okay, let's start our class, our lecture today. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. All right. So, before we go for the new topic for this today is the how to design the fuzzy logics, okay, using the MATLAB. So, before that, let refresh where we are learned last week's on the defuzzifications. Okay. So the defuzzification actually is to convert from the fuzzy set to the actual value or actual set. So this is some example. Okay, you can see on the slide example of the find the output. Okay, find the output using the all possible defuzzification methods. So last week we are studying about the 4 techniques. Actually, we have a lot of technique, but on the class we just focus on the 4 technique. There is the okay, so we have 4 techniques. We have the max. Okay, we have the max. We have the weightage average. Okay, we have the min max, and another one we have the center of gravity lah. Sometimes we call the centroid. Okay, we have 4 technique to solve our defuzzification lah. That's mean to convert from fuzzy set to the actual lah. So on the fuzzification, we have to find the last output. So the last output from this universe of discourse. Okay, so this on this part. So go to our system lah. Alright. So on this slide, okay, so you can see on the some example. Actually, this output, okay, this output you can see on this one, actually come from this one, come from the previous class we have studied. So, for example, this is output for B1. Okay, you can see this one, the slide. This is output for B1. Okay, actually come from the input. Okay, for example, input come. We select the minimum, so we have to select the 0.4 lah. For example, 0.4. Okay, for the B1, okay, for the B1, and then another waveform, output waveform is the B2, okay, B2. So B2, maybe we select the maximum lah. For example, we select the maximum, the connection select the maximum. That's why we have to select the 0.6, and then the total is the BT lah, or B. B is submission of B1 plus B2. B1 plus B2 lah. Alright, so this is how it come. So this output come from from the previous class. So the B1 plus B2, you got the B total here. So from this B total, we have to find the last output lah. So the output from the universe of discourse, to go for our system to our system. Alright. So if you refer this one, okay, actually it's come from this one come from this one. So we have B1 and B2. Alright. So and then actually we become like this lah. Okay, we become like this. Alright, so we have 4 techniques. Okay, to find the Z output using the possible defuzzification method. So first list out the 4 possible. Which one the possible? Okay, which one the possible? So the first one is the center of gravity lah. Okay, or centroid. This is all the output will be can use the center of gravity. So next, anyone can try? Anyone to try what the technique we can use to solve this one, to solve this output, to get the output? We have 4 technique. So which one the possible? Okay, so the one is the center of gravity. The all output. Okay, we can use the center of gravity. So the rest. Any idea? Other? Okay, we can use the min-max. Okay, we can use the min-max. Okay, we cannot use the max. Okay, this one we cannot use the max, and this one is not symmetrical. Okay, actually, if you refer this one, okay, this output actually this is not symmetrical lah. Okay, it's not symmetrical because this B1 is not symmetrical. This one B1 is not symmetrical. That's why we cannot use this which average. Which average. So only 2 method possible. For this output, only 2 method that we can solve to get the output lah. Okay, the first one is the center of gravity and second one is the means max. Okay, that's only two the method we can use to solve the outputs. Okay, that's why you can see this one. You have to solve all possible method. Okay, if you see this question, that means you have to solve. Okay, the solve four technique lah. But for this output only valid for two. Okay, for two technique. There is the center of gravity and another one is the means max. Okay, the means max. Alright, so and then another technique to solve this output, solve the simple one, the simple technique. Okay, there is the for this one is the simple is the means max. Okay, the means max that means okay this x output equals to this point plus this point divide by 2. Okay, divide by 2. Okay, alright. So 8.5. Okay, 8.5 plus.
Sorry, sir.
Yeah.
Is the screen is freezing or?
Because from the starting, doctor is start to teach, the screen is freeze there already, so no change on the screen there.
Oh no change. Okay. Sorry. Only the first slide lah. Only the example. Huh?
From the starting point.
Okay, only the starting point. Okay. Alright. Sorry. Alright, so okay. Alright, so actually, okay, can see this one. Okay, can see this one. Guys, can see this one. Actually, this output is from this one. Boleh nampak? Boleh jelas tak for this one? Combination between the B1, B2.
Doctor, cannot see the screen.
Cannot see the
Cannot see the share screen.
No content share.
no content. Oh, okay. Sorry. Alright. Okay, so this is our example tadi Nampak tak yang ni? This one. Clear this one
Yes.
Alright. So yang this one? Okay
Yes.
Second slide.
Yes, doctor.
Okay, alright. So I repeat again. Actually, these outputs come from this one lah. Okay, the previous class that I mentioned to you. So actually we have for example we have from the rules. Okay, from the rule, for example we have the B1 the output for rule number 1, for example B1. Okay, B1 here. So maybe the connection is N. So N, that means we have to select the minimum lah. That means we select 0.4 for example That's why this is the output for B1. Alright, so another one, the second rule maybe get this one So maybe the connection we use the or we select the maximum lah. Alright, so this is the B2. Alright, so actually from this B1, B2 we can get the B total lah. That's why at the end we have to find the B total actually. So the B total here is come from B1 plus B2, okay, and so on lah. If we have 9 output, that means we have to plus until 9 lah. Or we have 25, we have to add until 25. Okay, for the class maybe we just only 3 waveform 3 or 4 waveform lah. Okay, for example this one we have only 2. Okay, we have 2 waveform lah. That means we have the B1 and B2. Alright, so our B total will be B1 plus B2 lah. So this actually is come So this is how it come lah. Okay, from these outputs. Okay, that I mentioned before this lah. Okay, so from this output we can solve using 2 techniques. Okay, actually we have 4 techniques, but for this one the possible method for differentiation only 2 techniques lah. There is the center of gravity and second one is the means max. Okay, means max. So max we cannot use, and another one is the weight average also we cannot use because of, you can see this one on this previous B2 B1 actually is not symmetrical. Okay, for the weight average the output should be symmetrical. Alright, this one is not symmetrical you can see this one. So this one is this part is bigger than this one Alright, so that's why this we cannot use the weighted average because of the not symmetrical lah. Okay, so this output we can use only two techniques. There is the mismatch, the center. Alright, so and then another technique is you have to solve the simple one. Okay, the simple technique. Okay, for example, we have two techniques possible for this output. Okay, we have the mismatch and we have the center of gravity. So the simplest one is the mismatch. Okay, mismatch, because mismatch straightforward. Okay, the mismatch, the output will be 8.5 here. 8.5 plus 5.5 divided by 2. Okay, divide by 2. Okay, so the answer will be, okay, 8.5 plus 5.5 divided by 2. So the output will be 7. Okay, the output will be 7. So this one will be 7. Okay, this one will be 7. Alright. So next we can apply the center of gravity lah. So okay, center of gravity, first you have to make sure how many question. So for example, we have one question here, 2, 3, 4, 5. Okay, we have 5 question. Alright. Okay, so this is how to find the question number 1. Question number 1, okay, integration from 0 to 1. Okay, 0 to 1 here, 0 to 1. Okay, x, okay, we assume as the this universe of the course as the x minus 0. Okay, we put some x here, x minus 0 divided by 1 minus 0. Okay, multiply by 0.4. Okay, multiply by x dx. Okay, that is for question number 1, right? So maybe this one I cannot. Okay, I'll stop sharing first. I will use the okay, so try at the same time you can try. I will open the alright, so this one how to solve using the center of gravity that I mentioned to you. The first equation, okay, okay, this color. Okay, so we have question number 1, question number 2, question number 3, 4, and 5. Okay, so we have 5 equation. All right, so the first equation, find the first equation. This means integration from this point, 0 to 1, 0 to 1. Okay, so the equation here we put some x here. We assume this one will be x. All right, so we put some x value here. All right, so x here. So x will minus b0. Minus b0, that means x divide by 1 minus 0. So 1 minus 0 will be 1. Okay, so this is equation for this one. Multiply by, okay, 0.4 is the membership value. All right, multiply by x dx. All right, so this is equation number 1. Okay, get this one. All right, so we go for the equation number 2. Equation number 2. Okay, from 1 to 5. Okay, 1 to 5. 1 to 5. So this is only per constant. So we have 0.4 x dx. Right? This is for question number 4. So it's okay. For example, if this is on the, all right, same example for the under the equation. Okay, so x minus, okay, minus, okay, so will be 0.4 by x dx. Right, this one. So this divide by divide by integration of 1 to 5. Okay, 0.4 dx. Okay, so that's on the numerator. So next, for example, like third equation. Okay, third equation. Okay, integration from 5 to 5.5. right here. So the equation we can put like this. So the equation, this one, this part. Okay. So we can put as the x minus 4. Okay. This one. So okay, is okay. You can put this one. For example, I put here. So the answer will be x minus 4. Okay. 5.5. Okay. Minus 4. Multiplied by 0.6. Okay, this is membership value, and then x dx. Okay, so divide by. Okay, so this one same, but we cancel out the x here. So this is 5.5. Okay, x minus 4 divided by 5.5 minus 4, 0.6 dx. Okay, so on this part we cancel out the x. Okay, so question number 4. All right, so will be from 5.5, all right, to okay, 8.5. All right, this is constant, 0.6 x dx. All right, so divide by same. Okay, 8.5. Okay, 0.6 dx. All right, and then last one will be question number 5, from 8.5 to 9. Okay, so this one is we put some x here. Okay, x 9 minus x, because this one should be positive lah. Actually, this is equation. This slope will be negative, but on our membership value, so on the positive, on the positive value. That's why 9 minus x. So 9 minus x will be positive lah. Alright, so divide by 9 minus 8.5. Okay, 8.5. Alright, multiplied by 0.6. Okay. X dx. Okay, so divide by same, 8.5, 9. Okay, 9 minus 8.5. Okay, this one 0.6 dx. Okay, so this is on the divide lah. Okay, this part. Okay, for example, this is we call the x. This one will be y lah. So the output will be z divided by x divided by y lah. Okay, so first we have to find the x here. Alright, so x, this one. Okay, equation number 1 plus equation number 2 plus equation number 3 plus equation number 4 plus equation number 5 divided by y. Y also this one lah. Okay, equation number 1. Okay, plus equation number 2, equation number 3, 4, 5. Okay. Then at the end you can get the output. Okay, so from this one you can say, actually you can start using the calculator. Okay, for example that I mentioned to you, if you have used the old version, you can solve one by one. Okay, for example you can solve this one. Okay, 1, 1, 1, 1. But if you use the latest one, okay, for the calculator, so you can solve the whole question here. Okay, so this one times, okay, enter your data to your calculator and then divide by this one, one time. Okay, so maybe you just refresh on the calculator lah. So if you have the calculator right now, so you can try. I will show you some example. Okay, for example, okay, I will check my calculator first. All right, so maybe we have a okay, so for example, we have the integration from 0 to 2 x power of 2 okay, dx. All right, so this power 2, so okay, if your manual solution, you can solve like this lah, x power of 3 divided by 3, okay, 0, 2, okay, equals to, okay, so 2 power of 3 divided by 3 lah, divided by minus 0. So the answer will be 2.66667 lah. Alright, so that is the answer. So this is straightforward lah. But from this one, also we can use the calculator. So on your calculator, you can see on this symbol, right? So we have dx, this x. Okay, you can press this one, dx first. After press the dx, you have to press the alpha because we want to create the x here. Okay, so alpha. Okay, click that on alpha button, and then you have to click the symbol, right? The symbol here to create the x. Okay, so this one will be create here, and okay, this one will be create. Okay, this one will be create x. Okay, we will create the x, and then you have to click the on the x power of 2 lah, power of 2. Okay, power of 2 will be power of 2. All right, then you click the comma here. Okay, so you have to solve from the range. Okay, from 0. Okay, this one from 0. Okay, this is a comma. You have to click 0 and then click again the comma. This is comma, comma. All right, and then to 0, 2 lah. Okay. Okay, 2. Then you have to close. Okay, close the equation lah. Okay. Then you can get the answer lah. Okay, so you can get the answer will be same lah, 2.6667. So this one, how to write, how to solve using your calculator lah. So no need to use the manual lah. This one is simple. That's why you can straightforward using the manual lah. But if we have a lot of equation, will be take time lah. If you solve using the manual, also you can solve using the calculator. Okay, calculator, straightforward using the calculator lah. Okay, for example, this one okay, this is how to use the calculator. Okay, this one the integration alpha. Okay, so this one will be create the x. Okay, the x symbol x here. All right, x here, and then power of 2. Okay, you have to click on the power of 2, press power of 2, and then so on lah. Okay, so this is range. Okay, this is range lah from 2 to from 0 to 2, and then you have to close the equation. Then you can press the answer. Okay, the answer is okay, will be same lah with this one 2.667 lah. Okay, so that is how to use the calculator. Okay, boleh guys? So you can refresh balik lah how to use your calculator to solve the integration Okay, so this one so you can try this one to solve. Okay, so at the end you can after you use your calculator, you can check your answer. Okay, for example, okay, let me see. Okay, anyone already get the answer? This one, ada yang dapat jawapan tak for this one? Boleh somebody tell me what is the answer for this one? Dah try? Okay, what is the output using the center of gravity? Okay, so the trick, another one, the last part, you have to make sure your outputs, okay, your output should be from 0 to 9 in the middle lah. That means normally in the middle because the center of gravity is, okay, for example like this one okay, this one range from 0 to 9. If in the middle, maybe the answer maybe from 3.5 to 4.5. All right, that is the trick ones. Okay, after if you get the outside from this range, okay, from 0 to 9, that means your calculation is wrong. Okay, that's why you have to double check your integration. Okay, if you get out of range lah, that means if you get, for example, 9.1 out of range. Okay, out of range. All right, so that's why your calculation or your calculation integration maybe have something wrong lah. That's why you have double check lah. Suppose okay, this one maybe the result range from at the center lah, maybe from 3.5 to 5. Okay, that's it. Range that range lah, on that range. If you can get from in the that means your answer is correct, almost correct lah. Okay, that's why you have to try lah. So for the center of gravity, you can check on your answer. Okay, should be in the range lah, in the range and maybe at the center lah. Okay, because this one is not symmetrical because this shape is bigger than this one. So maybe more than 4 lah. Maybe for example, if the middle is 4.5, so after you got center of gravity maybe around 4.6, 4.9, something like that lah. Okay, you can try this one Okay, class. Okay, alright. So that's another tips. Okay, after you calculate your center of gravity, okay, using your calculator, and then if you can get range from 0 to 9 is okay lah. That means your answer is almost correct. And then normally at the middle, okay, center of gravity at the middle lah. Maybe range from 4 to 5, something like that lah. Okay, right. So that is another technique. Okay, and techniques. Okay, you can check your answer. Alright, so we go for today lecture is the design fuzzy logic controller using the MATLAB. Okay, boleh nampak tak slide ni? This one, design fuzzy logic controller using the MATLAB. Boleh tak kelas? Nampak tak slide this one?
Nampak Doktor, nampak.
Alright, so proceed So for today, so for the verification, and after this you can try lah to get the output. What is the output for verification using the center of gravity? Alright, so this one we go for the topic for today is the how to design our fuzzy logics using the MATLAB lah. So MATLAB is the one tools that we can use to run the fuzzy logic. Okay, fuzzy logic. Right, so this one is the fuzzy logic toolbox. Sometimes we call the fuzzy logic toolbox, or sometimes we call the fuzzy inference engine ataupun fuzzy inference system lah, FIS system. Okay, FIS file, or sometimes we call as the fuzzy toolbox. Okay, alright. So normally will be appear like this. Okay, so you can see this one So on the fuzzy logic designer, alright. So this one we have to set how many inputs, how many output variable lah. Alright, so what's their names? Okay, we can set their names. Okay, so on that I mentioned to you, so this one we can set two techniques inference. We can set as the Mamdani, or we can set as the Sugino on this part lah. Alright, so next we have the membership function editor. This one membership editor function. Alright, so this one is to define the shape of all membership function lah. Okay, for example, we can use the Gaussian. Okay, we can use the triangular, we can use the trapezoidal, okay, bell shape, and so on. Okay, after this I will show you how to use the MATLAB lah. This one, okay, just theoreticals on the MATLAB. Okay, this is another toolbox in the MATLAB. And then after you set the input and output, okay, this one also you can set the range. Okay, you can see this one, the range, okay, from 0 to 1 or 0 to 10, up to you. And then after you set the inputs and output, you have to set the rule editor. Okay, this one you have to set the rule. Okay, you set the rules. And then for this one, the rule viewer and surface viewer we can use to see the output lah. Okay, that's why we can use this one. Okay, rule viewer or surface viewer to diagnostic or to check our output, is it okay or not. So this one so after this we go using the MATLAB lah. Alright, okay, so this is some example. Alright, so this is for example like fuzzy rice cooker. You can see this one okay, first we need to identify the input and output variables of the process. So in this case we use the rice cooker system using the fuzzy logic. Okay, so this is system for rice cooker. We have the water and rice here. Okay, we have the heat sensor. Okay, we have this is our controller, and then this is our output lah. Okay, from this one we can define what is the input and what is the output. Alright, okay, for example we can set, okay, the rate of heating is our input, and also the amount of rice is our input. That means this is input 1 and this is input 2, or this is input 1, this is input 2. It's okay. Okay, that means we have, for this one we have two inputs. Okay, we have two inputs. Okay, first input maybe rate of heating. Okay, and second input we set the amount of rice. All right, and then our output will be temperature of rice. Okay, for example, this one only one output. Also, we can use for 2 output, 3 output, up to you. So for the simplest case that I mentioned to you before this, we focus on 2 input, 1 output. Okay, for example, this one, the input number 1 will be rate of heating. Second input will be amount of rice. Okay, and then the output will be temperature of the rice. Okay, so on this part, when you set the input and output, so you have to set the what type membership you want to use. Okay, we want to use Gaussian. Okay, you want to use the triangular, trapezoidals, bell shape, and so on. And also how many membership? 3, 5, 7, 9. Normally is the on the odd numbers lah, or number. Also can even number. It's okay, up to you. So for normally for simplicity we use the odd number lah. 3, 5, 7, okay, 9. All right. That is for how to set the inputs lah, input and outputs. Okay, you can see this one, the next slide. All right, so this one, so for example, this is input 1 and input 2. Okay, this one is the output. Okay, for example, we see the input 1. Okay, input 1, we have 3 membership. Okay, we have 3 membership. That means we have membership 1 is the low. We use the trapezoidal, we use the trapezoidals. All right, so membership 2 is the medium. We use the triangular. Okay, we use the triangular. And then third membership, we have the height. Okay, height. So we use the trapezoidals. Okay, also we can use the triangular. It's okay, up to you. Okay, either to this one. This is some example. Okay, for example, this one I use the trapezoidal at the both side. At the middle, we use the triangular. All right, triangular membership. Okay, so we have 3 membership for the input 1, low, medium, high. Okay, I mentioned to you. So we have 3 membership, low, medium, high. Okay, so this is input 1 and also input 2. Okay, input 2 I'll just follow the similar like input 1. So we have 3 membership. Okay, we have 3 membership. We have the low, medium, and high. All right, so at the same with the input 1 okay, and also the output I set similar like, okay, similar like inputs lah. So this one for output. Okay, we set as the 3 3 membership. We have the low, medium, and high. All right, so it's okay. So also you can set this one is 5. Okay, for example, we have set very low. Okay, another membership, very low, low, medium, high, very high. This is for 5. Okay, 5 membership. For example, if you want to set input number 1, we have set the 5 membership. This one for simplicity, we just use 3 membership. Okay, normal 3 we have low, medium, high, or we have the negative, 0, positive. Similarly, okay, that is for 3 lah. If you have you want to increase your membership, for example 5, so maybe we have the very low, low, medium, high, and very high. Okay, that is for 5. So if you have 7, so you can create another 2. Okay, another 2 membership lah. Alright, similar like input 2. Also you can create as the 3 or 5 or 7, up to you. Okay, it's based on our design lah. And also similar like output. Output pun also based on our design lah. So also you can set as a 3, 4, 5, 6, up to you. Okay, for example, you want to set the output will be different with the input. For example, I set this one is the positive. Okay, sorry, this one low is changed to negative, medium change to 0, and high change to positive. Okay, it's also can. Okay, also can. And then you have to know the range. Okay, the range for rate of heating. For example, rate of heating from maybe from 60 degrees Celsius to 100 degrees Celsius. For example, amount of rice maybe depends on your size of rice cooker lah. Maybe from 0 pot to 10 pot, for example, or 6 pot. Okay, 6 pot. That depends on the size of your rice cooker lah. Okay, and then this is the output. The output maybe temperature from, okay, you can set lah from 100 to 150, for example. Okay, the range. This is depend on our system lah. Okay. Alright, so this is how to set you can set the rules. Okay, that's mentioned to you. This one is the one technique we call the table metric. to set the rules. Okay, for example, this is amount of rice. Okay, input 1 Okay, this is input 1. This is rate of heating. Okay, this one rate of heating, and this one amount of rice. Okay, so amount of rice we have low, medium, high. Okay, there is membership. There is membership for low, medium, high, and also for second input we have 3 membership lah. We have low, medium, and high. That's why I mentioned to you, if we have 3 input on the input 1 and input 2 we have 3, so normally we have 9 rules. Okay, that's why we have 9 rules. Okay, and also we can write in the metric lah, table metric. This one we call the table metric. All right, for example, okay, this one is our output. Okay, this one our output. Also we have the 3 membership. We have the low, medium, or high. Okay, this one, for example, like rule number 1. I assume this one rule number 1. You can see this one. The relationship. If start the rule. If amount of rice is low, okay, and then the connection I select the n n. Okay, rate of heating is low. Okay, low. Then the temperature of rice is low. Okay, that is the rule number 1. For example, the rule number 1. Okay, and then so on lah. Rule number 2, rule number 3. Okay, for example, rule number 2. If amount of rice is medium, okay, is medium here, and I use the n connection, and rate of heating is low, then temperature of rice is low. Okay, this is the output. Okay, this is the output. Okay, next, for example, like rule number 3. I just go rule number 3. Okay, if amount of rice is high, okay, is high here, and okay, and all right, the rate of heating is low. Okay, then temperature of rice is medium. Okay, it's medium. Okay, so this is example how we set the rules. Okay, we set the rule using the table metric. Okay, this one we call a table metric lah. That's why we have the 9 rule. Okay, rule number 1, 2, 3, 4, 5, 6 until 9. Okay, we have 9 rules here. Okay, that's all. That's all for how to set the fuzzy logic lah. Alright, so after this we go for the MATLAB. We go for the MATLAB. Okay, so this some example lah. Some example. Okay, simulation using the MATLAB. Okay, so you can see this some our system lah. Some system they assume the mass of vehicle of 1000 kilogram, and the coefficient of the friction is 50 Newton meter per second. Therefore, the transfer function of the system is 1 over 1000 s plus 50. So this is our system lah. Transfer function we call our system. Our plan lah. Okay, this is our plan. Okay, this plan come from this system lah. From this one. You can see some example. Alright, so before this, okay, maybe before this, you study how to design using the PID, okay, using the pitch control, okay, using the P control, okay. For example, this one using the P control, using the gain, only the gain. Okay, so this is our system, our model, okay, dynamic vehicle dynamics, and then we can get the output lah. Okay, so this is the simulation result. Okay, then so we start design the controller using the MATLAB. Okay, that mentioned to you. After this, we go on the MATLAB. First, we have to set the inputs. Okay, the inputs, and then set the Mamdani lah. So either you want to use the Mamdani or Sugino. So on our class, actually we have the Mamdani and Laksen. Laksen, but on the MATLAB we have the Mamdani and Sugino. Okay, so after that I will explain what is the difference between the Mamdani and Sugino lah. Okay, so this is the outputs. Okay, on this one you can change the name lah. For example, you want to change the name number 1, input 1, input 2, and output. Okay, this one you can set. Okay, normally defalsification, you can see here on defalsification we use the centroid. Okay, the centroid that means using the center of gravity lah. We use the center of gravity. Alright. Okay, second part we have to select lah, or we have to design the membership. Okay, membership lah. For example, this one we have three membership. Okay, for example, input number 1, we have three membership. They are set as the negative, 0, positive, for example. Okay, negative, 0, positive. So they're set as the triangular. Okay, triangular, they use the triangular. Okay, this one, this one for positive, this one for 0, and this one for negative. Alright, so this is input 1. Okay, also you can change the parameter here, change the parameter here. Okay, also this one for the range. Okay, for example, negative 20 here to 20. Also you can adjust lah. For example, you want to set as the from negative 10 to 10, so you can adjust here. Alright, so that's why we have, before we design, we have to know the range of our input and output lah. Okay, so that you can set on the fuzzy. Okay, so this one we can set the range. Okay, the range for input variables, velocity error, so from negative 20 to 20. Okay, so this parameter for negative lah. Also you can adjust from this point to this point. Alright, so this is a similar like input. Okay, input 2. Okay, click on the input 2, you can adjust lah. Alright, you can see this one, the range I changed from negative 5 to 5. Okay, for example, this one, negative 5 to 5. Okay, alright, so also this one we can you can name it. For example, as the negative. Okay, this one is the positive. Okay, that means 0. Okay, so this one set as the NA. That means negative acceleration. This one 0 acceleration, and then this one is the positive acceleration. PA, up to you. Okay, you can put as you want the name. For example, negative 0, positive. Okay, and this is for outputs. Okay, the output is the engine force. For example, okay, for example, you can see the range from 0 to 1000. Okay, you can see this one. Before this, the MATLAB, okay, I think MATLAB 2006. Okay, 2006. So there's only, you can run from the negative 1 to 1. Okay, the output, or the input, also the input. Okay, you have to run from 1, okay, 0 to 1, or negative 1 to 1. Okay, that's why we need normalization, normalization. But nowadays, so the latest software, we don't need the normalization. So straightforward using the actual, okay, using the actual value. For example, our output is the range from 0 to 1000. Okay, also on the MATLAB we can set as the 0 to 1000. Okay, and then after we get this one, okay, this is go for our system lah. Alright, so that's why nowadays the latest version of the MATLAB, we can set follow the actual value lah. Okay, the actual value is for example from 0 to 1000 or 0 to 10,000 also we can set. Okay, we can set here. Okay, right. So this is set the outputs. Okay, input and output will be same. Okay, will be same here. So you can set on the membership function editor lah. Okay, so this one we can set lah. So for example, we can change the shape for membership. Okay, this one we can change to the trapezoidal here. Okay, after that I will show you. Okay, this one triangular. This one triangular membership function. Alright, so we can change. Okay, for example, we click here, we can change to the trapezoidal. Also, we can change to trapezoidal, or we can change the Gaussian. We can change the bell shape and so on. Okay, that is for on this membership editor. Okay, alright, and then next is the rule. Okay, you have to set the rule on the rule editor. Okay, based on the table that I mentioned to you. For example, before this, we have 3 input. We have 3 input 1 and 3 input 2, and for the simplicity we have 9 rules. That's why you can see we have 9 rules. Okay, maybe you can first for simplicity we can set a table first, table metric, then we can follow the table metric lah. Okay, you can see this one. For example, like rule number 1. Rule number 1, if velocity error is negative, okay, negative, and the connection we use the n here, all the n lah. So also this one you can change. Okay, the connection, if you want to use the N, okay, or you want to change to O, you can change here, the connection here. The rest weight is maintained as 1 lah. No need to change. Okay, the weight no need to change, just maintain 1. Just connection. So either you want to use the O or N. Okay, for example, if you select the O, that means we have to select the maximum. If you select the N connection here, so we select the minimum value. And then you can see velocity acceleration is the negative. Okay, then the engine force is minimum, right? Okay, so this one is on the rule editor. After this, we go for step by step on the MATLAB. All right. Okay, so this is how to implement in the Simulink. Okay, so this one, this part. Okay, before this, we use the fit scale. Okay, we change from PID or fit scale. So the conventional controller change to fuzzy logic controller lah. Change to this one, to fuzzy logic controller. Okay, and then you can run. So this is simulation lah. You can get the simulation. Okay, so we'll stop here. I will show the how to run the fuzzy using the MATLAB. Okay, make sure you have install your MATLAB on your PC. Alright, I will share the MATLAB. Okay, will be take time because will be appear one by one. On the MATLAB will be appear box by box. That's why I have to share and share. Okay, wait. Alright, can you see MATLAB 2015A? Can you see my slide? Nampak tak my software MATLAB 2015? Yeah, if you have latest, that's good. So my PC, I just install MATLAB 2015. Nampak tak MATLAB this one?
Nampak Doktor?
Clear tak?
Nampak.
Nampak Alright. So so you can open your MATLAB if you have the MATLAB on your laptop now. Alright. So on the command window here, you can see on the command window, alright, type fuzzy. Okay, you have to type fuzzy. Okay, type fuzzy will be appear the fuzzy toolbox. Okay, this one I will show you. So type here on the command window. Okay, on the command window, type fuzzy will be appear. Alright, so now will be already appear. I will share the okay. I will stop share. I will share the fuzzy logic designer. Alright, can you see this one? Fuzzy logic designer. Okay, nampak fuzzy logic designer. Alright, so this one on the fuzzy logic designer you can set. Okay, this one you can set. So this one on this sometimes we call the FIS. Okay, FIS fuzzy inference engine, or sometimes we can fuzzy toolbox. Okay, so this one we can set as the inference engine. Inference engine we can set as the Mamdani or Sugino. Alright, so this one Mamdani. Okay, so example for the class we use the Mamdani and Laksan. So I set as the Mamdani. So Mamdani. If you want to set Mamdani, okay, you set Mamdani lah. Okay, so and then for example here for the first you can see this one. So we have only one input and one output. Okay, but for our example we want to set as the 2 input 1 output. So you can go for the edit here, add variables. So you can add the input right? You can see this one. For example, you want to add output. So, okay, will be 2 input 2 output. Okay, for example, okay, so I just remove the remove. Okay, so now we have 1 input 1, input 2, and 1 output. Okay, all right. So if you click here on the input, okay, so you can change the name here. For example, okay, I change the name, any name For example, input 1. Okay, you can put as the error For example, the name I change the error for the error. Okay, so automatically will be changed to the error here. All right, so input 2, click on the input 2. Okay, you can change here. Okay, for example, input 2 I set as the data error. Data error. All right, so will be appear this one. Will be appear data error. All right. Okay, and then the output, click on the output, and then you can change. Okay, for example, the output. Okay, temperature. Okay, temperature. All right, so will be change the outputs. Okay, so this one on the fuzzy logic designer. Okay, the next step we have to set the membership, the membership for the every input and output. Okay, that's why you have to double click here. Double click any, for example, double click on the any input, will appear another icon, will be appear membership function editor. So I will share. Okay, I will stop share for the fuzzy logic designer. I will share for, okay. Okay, so will be appear this one, will be appear after you click on the input, so will be appear this one, membership function editor. All right. So on this part, you can set how many membership function. Okay, what type of membership function? For example, input number 1. Okay, so I will change this one. Change the name. Maybe I check as the negative. Okay, negative, and this part I change to the trapezoidal. Okay. You can see this one, I change the trapezoidals, okay, or you can change another type lah. So we have the Gaussian, we have the bell, okay. For example, we have sigmoid and so on. We have the S membership function, Z membership function. For example, Gaussian, okay. We be changed. This is Gaussian membership function, okay. For our class, normally we use two lah, triangular or trapezoidal. Alright. So this one parameter, okay. You can change from this one parameter if you know. Or you can change here, okay, just on this point, okay, you can change. You can see this one, click on this point, you can change lah, follow your value you want, okay. This one, you can change, or you can click here, you can change this one, right? You can shift to the left, shift to the right lah, okay. For example, okay, maintain this one, right? And then also the range here, so maybe the first input I set as the negative 10 to 10 lah, for example, so click here, automatically will be changed, okay. This one, you can see this one will be changed to negative 10 to 10, okay. Okay, so this one, for example, like input 1, input 1, and then for membership 1 is the negative. All right, so next I will change to the membership 2, to the, this one I change to the 0 lah, okay. The name is 0, okay. Maybe click here. And then you want to change the shape, okay, of the triangular, maybe like this, okay. So the range, okay, you can set this one, okay. This one membership 3, maybe you can change as the positive, and then you change to trapezoidal, for example, okay. And then I change the range, okay, the range, maybe like this. Okay, right. So this one for input 1, for input 1, for error, for example, you can see this one, input variable is error, input 1. Also, you have to do on the input 2 and also for the output lah. Okay, so for input 2, okay, it's a similar. Follow the simple, okay, on the slide. Before this, I set as the negative, okay, I set the negative. Okay, this one I set as the trapezoidal. Okay, I change the range here, and then second. Okay, I set as the 0. Okay, set 0. Okay, and then you want to change this one also, okay. All right, up to you. Okay, this one membership 3 I set as the positive. Okay, so maybe set as the trapezoidal. Okay, okay, maybe like this. Okay, maybe the range also you can change lah. Okay, the range maybe from negative 1 to 1. Okay. So automatically will be changed from negative 1 to 1. Okay. Alright. Okay. After that, we have to also change to the output The output the output also you can change I put as the similar similar like this one negative, or put as the negative. Okay. So okay, maybe I set as the trapezoidal. Okay. On the both side, I set as the trapezoidal. Also, you can set as the triangular, okay, or another technique, another membership function. So we have a lot of membership function here. So we have the trapezoidal, Gaussian, and so on. That I mentioned to you on our class. Normally we use the triangular or trapezoidal. Use a trapezoidal. Okay, so this one we set as the 0. Same. Okay, so maybe we change the name lah. So this one is the medium. So I put the medium lah. Put the medium. Okay, this one I set as the small lah. Small another different lah. Small here. Okay, this one I set as the triangular. So triangular. Okay, medium. And this one I set as the like big lah. Big. Okay, big. Okay, I set as the trapezoidals. Okay, you can see this one. So this is on the outputs. Okay, on the output I set on the temperature lah. So I set the membership function as the small, medium, and big, for example. So the range up to you lah. For example, you can set from 0 to 1, or maybe I can set from 0 to 10 lah. Okay, 0 to 10. Okay, will be changed 0 to 10 lah. Alright, and then last part. Okay, on the fuzzy logic toolbox, you have to set the rules. Okay, go here, edit. Okay, set the rule. Okay, will be appear rule editor. Okay, click on edit. Okay, click edit and then set on the rules. So will be appear the rule editor lah. Okay, will be appear rule editor. I will show you. Okay, rule editor. Okay, will be appear this one. Will be appear rule editor. Alright, rule editor. So this one. First, that's why you have to draw the metric table. Okay, for example, from the metric table you can write the rules lah. For example, like rule number 1, if negative, input number 1 error is negative. Okay, the condition is n here. Okay, then the output will be I put as a small, so you can add here. Okay, so will be appear the rule number 1. Okay, rule number 2, I set the 0, 0. Medium, for example, and add rows. Okay, add rows. Okay, so will be rule number 2 and so on. 3 I set as the bigs. Okay, so for example, I mentioned to you, if we have input 1 we have 3, input 2 we have 3, that means we have 9 rows lah. We have 9 rows. So this is some defaults lah. That's some what we call it the simplest method lah. So that means based on our input 1 and input 2, that means we know how many rows. But it's okay if you want to more than 9 rules. Okay, for example, you want to set 50 rules. Okay, or less than 9. For example, just only 3 also can. Okay, it's not we don't have specific number of rule lah. Depends on the output. Okay, on the output. If after you run on the simulation, you get the best output. So that's it. So for example, only 3 rows. So it's okay lah. Only 3 rows. So for example, if you design 9 rows but the output is not good, so maybe you can add another rows and then the result will be better. So that's your rule lah. So maybe we have to add another rules. Okay, but it's not specific. Either you want to set as the 9 rules, 6 rules, 12 rules, so it's okay, but it's the standard for simplicity that we just for you just follow the input, how many input 1 and how many input 2, you just multiply. For example, input 1 we have 3, input 2 you have 3 membership function, that means we have 9 rows. Okay, we have 9 rows. Okay, and then this is an example lah. You can set. Okay, you can add another 6 rows. For example, this one I just show for the 3 rows lah. Okay, from this one, okay, you can click here. Okay, you can click on the view. Alright, you can click on the rules. Okay, rule or surface lah. So this one you can see on the rule viewer or surface viewer lah. So normally we just focus on the rule rule viewer. So you click on the rule viewer, will be appear the rule viewer lah. Okay, you can see this one. Alright, so will be appear the rule viewer. So this one, you can see we have only 3 rows. Okay, if you have set 9, so will be appear 9 lah. Okay, this one I just set 3. I just set 3, so will be appear 3 row lah. Okay, you can see this one So this one on our class So for example, okay, so this is point input 1, okay, input 2. Okay, you can see on the class. So on the class the connection is n. The connection is n. That's why we select the minimum. Okay, on the class you can see so this is input 1 and input 2. You can see if the connection is n, okay, the connection between input 1 and input 2 is n, so we select the minimum. From this one, this is minimum. Okay, that is we can get how we get the output here. Okay, this one we call as the B1 B1 this one is the B1. How they get for example, you can change. Okay, next second if you change this one, okay, change to this one. Okay, change the small one here. So the connection I use the n n, that means they select the minimum. Okay, for the second rule select the minimum. So that's why here the output will be here, and then alright, so this is B total. Okay, this one you can see this is B total. That's why you can see B1 plus B2 plus B3 actually. So okay, I will show some. Maybe we have 2. Okay, so this one you can see that's why B1 we don't have the output. Okay, we have a B2 and B3. Okay, you can see so B1 plus B2 plus B3 lah, but B1 we don't have the output here. So that's why the B total we get here. Can see this one so we can get here lah. That is we call the B total here. Okay, that's why B total will be B1 plus B2 plus B3 lah, but B1 we don't have the output here, so only B2 and B3. And then at the end we use the center of gravity to get this red line is the output lah. Okay, the output range from 0 to 10. That's why the output here will be appear here. Okay, 7.45. Okay, you can see this one 7.45. That means the using the center of gravity, the range from 0 to 10 lah. Okay, 0 to 10. Okay, maybe because this one is small, this one is the big, so that's why more than 5 lah. Okay, for example, this the center is the 5, so because of this biggest, this size is biggest, that's why you cannot see anything. Oh, tak nampak Alamak, penat cakap ni. Tak nampak this one, the rule viewer. Nampak tak nampak? Nampak Okay, tak nampak kata. Nampak Okay. Kejut juga sebab ada yang kawan awak Akmal Syafi kata cannot see anything. Alamak, tu yang saya. Okay, nampak. Okay, right. Risau je tak nampak tadi. Okay, this one if for example I stop sharing, I go for this one, do the rules. Okay, this one rule editor. So you can see this one I change. Okay, for example, rule number 3 I change to all. Okay, rule number 3 I change to roll. Okay, you have to click on the change rule. So you can see this one will be changed. Rule number 3 I choose the all, and also number 1 I choose connection all lah. Okay, change rule. So you can see this one rule number 1 and rule number 3 I change to all connection So that means if all we have select the maximum. Okay, that's why after this you can see the rule viewer lah. Okay, I stop share. Okay, you can see this one So rule number 1 and rule number 3 will be all connection. That's why I choose this one You can see this one. So this is input 1, okay, and input 2 here. Alright, so the connection is all. That's why we select the maximum. Okay, you can see this one So how it selects this one? It select the maximum. Okay, so maybe another one So maybe rule number 3 Rule number 3, you can see this one So rule number 3 also I choose the connection all. Okay, so you can see the rule number 3, the input 1 and input 2. Okay, so we select the connection is all, we select the maximum. That's why here the output will be on the maximum. Okay, you can see this one That's why this is output for membership. Output for Mamdani So Mamdani, if we use the Laksan, so Laksan will be, our output will be like this lah. how to choose the connection. Okay, on the rules. Okay, this one how to choose the connection. Okay, I'll share again. So this one we can change here. Okay, you can change here connection here. Okay, kita nampak tak how I change the connection here. Okay, this one you can choose either you can choose O or N. Normally for simplicity just choose the N lah. Okay, that's why you can see on the my slide before this. Normally all the rule I choose the N lah. Okay, but for the midterm or for the final normally I change lah. Okay, this one for midterm and test maybe I change to O and N lah. Okay, but for design, okay, but for if you want to design the fuzzy logic, maybe you can set as the only one lah, one connection either you want to set as the O or N lah. Okay, for simplicity better you set all the rule is the N. Okay, N. This one I want to show lah. So if you choose the O, so what happened? Okay, if you choose the N connection, what happened? Okay, so that's why I want to see. Okay, see what's the difference between the if you choose the O and N. Alright, N connection lah. But if you want to design using the MATLAB, so no need to change lah. Okay, no need to change to O to N. Okay, rule number 1 or rule number no, just fix only one lah. For example, you want to set all rule number 1 until 9, all the N is okay. Okay, right? So this one is just example for the test for the midterm to you understand lah. Okay. Alright, so that's all. That's all for fuzzy logic toolbox. Until this one, until after you set the rule editor, okay, and then you specify your output, you can check on the this one. For example, okay, start sharing here. Okay, this one, okay, you can check the last, you can check here. So after you specify, for example, you go for -10, this is -1, so the output will be the temperature is 1.32. That means you think your this output will be okay. Okay, then you can apply to the Simulink. Okay, this one that's it for fuzzy logic toolbox. Okay, until you set the rules, then you can apply using the Simulink. Okay, clear this one? Okay, for the fuzzy logic toolbox until the rules, So next. Okay, you have to go for the MATLAB again. Okay, MATLAB toolbox here, MATLAB this one. Alright, the MATLAB 2015. Alright, go for the new. Okay, go the Simulink model. Right, to appear the Simulink lah, the Simulink model. Okay. When we click this one, okay, click on the new, okay, click on the Simulink model will be appear the Simulink lah. Okay, this one I will show some example. Okay, wait So if you install the latest one, so maybe your the size of MATLAB will be bigger lah compared than you install the 2015, 2000 9 or 2012. Okay. If you install 2019, so your file, the file will be bigger. Okay, will be bigger. I think I'm not sure, but will be bigger lah. So that's why if your performance, your PC performance is not so good, so that's why very slow. When you run the simulation, okay, very slow lah, take time, but it's okay, right? As long as you can run the simulation, it's okay lah. Okay, so I stop sharing here. I will show. Okay, so we appear this one So we appear the Simulink lah. Okay, this one the Simulink. We have to design the fuzzy logic lah. Okay, so this one you can click on the library. Okay, on the library, right? You can click on the library. So will be appear the library lah, the toolbox. A lot of toolbox will be appear. Okay, all right. So for example, on the simulation, okay, so we use the transfer function. Okay, we use the first of all, maybe you can use the PID PID first. Okay, sync. Alright, you use the scope to see the waveform. Okay, so source, you can use the step input. Okay, alright, and then we have the marks here. Okay, we have the marks. It's moments. Okay. Okay, we have some here. Okay, so this one Alright, so this is a simple example using the Simulink. Okay, just click here. Okay. Okay, this some example. So plan, maybe we follow the plan that on the slide. Okay. So or another plan is okay. So for example, our plan before this is 1000 1000. Okay, 1050 or 1050. Okay, so we pair like this lah. So this is our plan For example, this is our plan. Okay, this one will be, we have to change was plus plus, we have this one will be negative lah. Change this one negative. Okay, so will be change this one the will be positive here lah. Okay, this one positive, this one will be negative. Right, so this is our PID So this is, for example, like how to design the PID controller lah So this is our system. Okay, and then you can run lah. So maybe I set as the 50. Okay, and then you can run. Alright, so will be, and then you can click on the double click on the scope, will be appear the result lah. Okay, I will show the result here. So we cannot move. So maybe I can run 500. Okay, 500 first. Okay. Alright, so okay, I will show you sharing to you. Okay, so this is output. Okay, this is the output lah. Okay, using the PID. Okay, using the PID. So this is our outputs. Okay. Alright, so you can see So you can study on the performance this one for rush time. So what is the value for rush time? Okay, the overshoot. Okay, the steady state error and so on. Okay, this one from this scope lah. Okay, so. Alright, so can back to the Simulink. Okay, back to Simulink. So actually on the PID we can auto tune lah. So you double click on the PID. Okay, after you click on the PID, so will be appear the function block parameter lah, PID controller. Alright, so here wait, I will show. Okay, will be appear this one will be appear function block parameter lah on the PID controller. So normally we can set the value of P, I and D. This one P, I and D. This one. So for the PID normally we can use this one auto tune. We call the auto tune lah. Click on this button. Okay, this tune. So automatically we be find the optimized value for P, I and D. Alright. So no need to use the, for example, like if you study on the control system, normally you use the board plot, okay, Nicholas chart and so on. Okay, but nowadays you can use straightforward. Okay, so will be appear. We share the output. Okay, will be appear like this. Okay, after you click the tune, will be appear like this. Okay, this is original one. All right, so the normal one. So you can see the block. The block response before this. This is new one. So the rush time will be better than before this. But we have some overshoot here lah. That's why okay, we have to use the fuzzy logic to overcome this overshoot, right? That's why we need fuzzy logic, right? So you can see the parameter. Okay, from this one you can see the parameter lah, parameter for PID, right? So this one, okay, will be appear. Click on the show parameter, so will be appear the controller parameter for PID lah. So for example, you can see on this we have the normal before tune we have 110. Okay, but after tune we have for P we have 66 point something, I we have 6 point something, and D is the negative 48 something lah. So we be get this response and then you can see the performance. Okay, also you can see the performance. For example, you can see the rise time. Okay, the rise time before this is the 78.8 second, but after you tune you can get 70.3 second. Okay, will be improved lah. Okay, also the setting time point also will be improve. Okay, improve using the auto tune, but unfortunately it's not good for the overshoot. So the overshoot here for the tune will be higher than the normal one lah. Okay, so the normal one is the 1% something, but for the tune get 7 point something percent. Okay, that's why. Okay, that's why we need, okay, this one we need the fuzzy logic to improve this overshoot lah. Okay, all right. So if you are okay, you can update your block. Okay, so be like this, and then you can run again. Run again your Simulink. Okay, click here. Okay, click here. Okay, run again yours. Okay, after you okay, update, automatically your PID will be changed lah. Parameter will be changed. Follow the update one lah. So and then you can run again. You can run again, and then you can check on the scope. Okay, click on the scope. Okay, so they said, okay, you can get the your output lah. Okay, for example, okay, so this is our new, okay, new output lah. Okay, new output. You can see this one, new output. So will be improved lah compared then. So will be improved on the rise time and setting time lah. But the overshoot will be bigger compared than before this. Okay, that's why we need fuzzy logic here to overcome this overshoot lah. Alright, so next, stop share here. We go for the Simulink gain. Okay, we go for Simulink gain. Okay, here. So on this part, we have to design the fuzzy logics. Okay, on the fuzzy logic. So go for the library. Go for the library. Alright. So click here. So on the library, you can check fuzzy logics. Fuzzy logic toolbox lah. Okay, fuzzy logic toolbox. Okay, will be appear this one. So you can write. This one is the fuzzy logic toolbox. Okay, on the fuzzy logic toolbox, we have the membership. Okay, membership function. We have the fuzzy logic controller using with the rule viewer lah. So normally we use this one, fuzzy logic controller. We use this one, fuzzy logic controller. Okay, so maybe you can copy this one. Okay, copy. Okay, paste. Okay, so we just change the PID to the fuzzy lah. Okay, this one maybe this. Okay, the input we share to this one. Okay, all right. So we go to the fuzzy. Okay. Oops. Okay, this one I go for this one, double click here. So maybe change to 3 lah. Change to 3. So we can go here. Okay. Right, so on the fuzzy, I mentioned to you, on the fuzzy before this we have two input. Okay, this one only one. That's why we have to delete this one. We have to put some marks here. But we have two marks. Okay. Okay, right, goes here. So another one we can create as the integral, or derivative. Okay, derivative. Data error. So go for library, go for continuous. Okay, we use the derivative, or we can use the integral or derivative. Okay, we can put this one and another one here. All right, so that's all. That's all how to design the fuzzy logic. So this one we can cancel. Okay, this one can. All right. Okay, this one how to design the fuzzy logic controller lah. Okay, so we use the same model. Okay, same plan here. Okay, same transfer function here. All right, but this one before this we use the PID. Now we use the fuzzy. Okay, so before run, okay, we have step lah to run. Okay, to run this one. First, you have to double click here. Double click on the fuzzy logic controller will be appear. Okay, will be appear this one. Will be appear. Okay, will be appear this one. Will be appear file name lah. Okay, file name. So on the fuzzy logic toolbox that you have designed before this, you have to save. Okay, you have to save what name. Okay, you have to save the file lah, the save as the file lah. For example, you put as the any file lah. For example, you put as the fuzzy. Okay, make sure before on the toolbox, fuzzy toolbox, the fish, you have to save. Okay, the save name. Okay, and then apply. Okay, all right. So will be appear. Okay, will be like this. Okay, sorry, this one. Okay. Okay, but still cannot run. Cannot run. Okay, you have to. Okay, that's another step. Another step. Okay, so on the fuzzy logic we have the another step before run. Okay, you have to go back on the fuzzy on the. Okay, go back on the command window. I will share the. Okay, I will share the command window first. Okay, go for command window. Okay, this one you have to type fuzzy. Okay, will be appear the fuzzy. Okay, will be appear the fuzzy. But you have to before this you have to. I will share that. I will share first. Share. Okay, so after share this one, so this is after click fuzzy on the command window will be appear this one, fuzzy logic toolbox or fuzzy logic designer. So click. Okay, so you have to import. Okay, before this you are design and then you have to save. Okay, make sure you save from. Okay, you just import. Okay, for example, I save from the file. Okay, from the file I save as in the desktop. Okay, fish file. All right, so will be appear before this. Okay, will be appear this file. I will show you some stop sharing. Okay, I will share the new one. Okay, so we share this one. All right, will be clear. So this one before this, design the input and output. So I will save as the fuzzy. This one you can see the name here. I change to the fuzzy. All right, save to the fuzzy. All right, and then will be appear fuzzy. Then the last step you have to go for file, export to workspace. Okay, the last step before you run the simulating, you have to go for the export, go to workspace. Okay, go to workspace. Okay, click here, and then you can see the this one another appear icon. So just okay, click okay. Okay, so I back again. Okay. Alright, so you can see on the this one. Alright, you can see this one. On the workspace we have the This one, we have the fuzzy file, okay, that you are designed before this, the fuzzy file, right? So this one, okay, here, right? So then you can run, the simulink, okay? Then you can run the simulink lah. Okay, maybe I show you some example before this, already designed. For they already designed the fuzzy logic controller. Go for simulink, open file, Okay, so I will share you some example that I do before this. Okay. Okay, right. So you can see this one. So this is some example that I just designed before this. All right. So this is for the lab. Okay, that we use for the lab control. Okay. So first we have to design the PID. Second, we have to design the fuzzy logic. You can see on the fuzzy logic here. So you double click on the fuzzy logic, so you can check the name lah, the file name that on the FIS file on the fuzzy inference system or fuzzy logic toolbox. Okay, and then you can run, then you can check the scope. Okay, you click the after you run. Okay, run here. All right, so will be will be clear here. Then you can double click on the scope. You can check the performance lah. Okay, performance of your output lah. So for this case, fuzzy is not good because I not tune again. I not can we show the output here? I will share the output, okay, from the scope. Okay, but it's not so good, okay, because we have to tune. Okay, this one Alright, you can see this one So this is on the blue line here will be is our fuzzy our fuzzy, and this is our set point, the what call the not the line here, and then the yellow here, yellow here is the purple here is not is the set point, and the yellow here it will be our PID. Okay, so the PID. Suppose our fuzzy will be follow the set point lah. Okay, this one, that's why you have to tune your fuzzy. Okay, because you can see this one the output for fuzzy is not so good. Okay, it's not so good. Suppose it's better than the theoretical fuzzy better than PID. Okay, that's why after you get this output, so you know your fuzzy is not so good, you have to tune. Okay, so you have to tune. I will show you how to tune the fuzzy logic. Okay. Okay, stop sharing first. Alright, so on the fuzzy logic, how to tune. So we have a lot of technique that I mentioned to you. So but no specific techniques. So first technique we can adjust. Okay, you can see this one. We can adjust the range. Okay, the range for the input and output. Okay, for example, you can change the range. Okay, maybe I change to -10 to 10. Okay, try one by one. Okay, that's why fuzzy is still complicated lah, because of you have to know the parameter, exact parameter lah for your system. If you know, okay, so no need to change the range. Okay, for example, you know the error maybe from 0 to 1. Okay, for temperature maybe you set as the from 10 to 100. So that's why we have to know the system lah. But if you don't know, so that's why we have to try and error. Okay, try and error to get the best range. Okay, the best range for the input and outputs. Okay, and then after every time, okay, make sure this one every time you adjust the the parameter or the setting here. Okay, that you change this one. Okay, for example, you change this one. Okay, for example, shift to the left. So automatically, every time you change, so make sure file, go export to workspace. Okay, and then run against Simulink and then check the output. Is it okay or not? You change the, for example, you have to do one by one, step one by one. First, okay, before this, I change this one. Okay, the initial, for example, the initial is the, okay, the initial value is the 0 to 1, and then we get output is not so good. The output is not so good. So the next step, I change to this one. 10, negative 10 to 10. Okay, this one you can see will be changed 10 to 10, and then I go for file and then go for export to workspace. Okay, and then run again simulation, run again on the Simulink, run again Simulink, check the output. Is it okay or not? If not, okay, go back to the fuzzy. Okay, check again. So another technique, you can change this one. You can change the mapping of the membership function. So you can change, maybe you can do a small one here. Okay. Okay, change this one. Okay, right, something like this. After you change this one, okay, before you run the Simulink, make sure go file, export to workspace. Every time you change the parameter for fuzzy logic toolbox, and then you have to export to workspace. Okay, go for export workspace, then you can run the Simulink. Okay, then you can run the Simulink. Okay, make sure every time you run, you adjust the parameter, you have to export the file to workspace export this file to workspace, and then you can run the Simulink. Okay, if not you not export, so we will run the previous, okay, the previous membership, the previous fuzzy logic lah. It's not the latest one. Okay, for example, you adjust this one, the range, for example, the mapping here, and then go for the export, okay, to workspace. If not, so will be maintained before this. Okay, the before this maybe just something like this lah. Okay, the output is not so good, will be same. That's why every time you change, okay, every time you change this one, okay, so make sure go for file, export. Okay, go for export. Okay, for example like this okay, go export and then okay, then you can run the Simulink lah. Then you can run the Simulink. Okay, so another technique. Okay, so this is technique you can adjust on the membership editor. So another technique is the rules. Okay, another technique. Okay, another technique we can adjust on the rules. Okay, so this one. Okay, all right. So we can adjust this one So that is another technique that we can adjust. Okay, this is we call the tuning process. Tuning process of the fuzzy logics. All right. So first we can change on the output range. Okay, and then we can change on the mapping of the membership. Okay, mapping of the membership, and then the last part we can change the rules. Okay. So normally the rule will be fixed. Okay, that's why I mentioned to you. The rule we just follow the default rule. Okay, for example, we have 9 rule. Just follow the 9 rule, and then we just adjust on the range for the input and output. Okay, for example, like before this you just change the output Before this, you set as the 0 to 10. Maybe you can try from 0 to 100. Okay, or 0 to 1000, for example. Change the range. Okay, or you can adjust the mapping. For example, the mapping. Okay, you can shift to the left or you can shift to the right. All right, this is how to tune the fuzzy logics. Okay, class. Right, so that's why after this, don't worry. After this, you have you can share, you can watch again my video here. Okay, so you can run again your fuzzy logic. So on the next week, we try to discuss about the structure first. Okay, discuss about our assignment. So share. Yeah. Right. Okay, wait, share. All right, so this is our okay, our assignment. Okay, nampak tak kelas? You can see this one assignment. So this assignment we have, you can see this one on this slide. Not is the words. Okay, we have 15. Okay, that means we have 15 plant. Okay, every plant is different. You can see on the transfer function. All right, this one on the transfer function here. All right, so this one I just cut from the AUV yaw control. For example, plan number 1. Okay, this is plan number 2. So every group will be do the different plan. So it's not the same plan. So that's why I just give a lot of plan, a lot of system. So you can run. Okay, you can run for using the Simulink. Okay, but you have to change this transfer function. Okay, first you have to design. Okay, you can see this one. The assignment. Okay. This assignment, you have to design the fuzzy logic controller. Okay, for the assignment, student will be needed to create a group consists of 3 members. Okay, so this one is okay. You want to choose or you want me to choose? Up to you. Okay, after this we discuss about the assignment, and then each group will be come up and design the fuzzy logic system for any real application. For example, I already give the model, but okay, for this semester, maybe I open. So if you have another plan or another system, okay, for example, for any real-time application, so also you can use lah. Okay, for example, like I mentioned to you, you can use the heat transfer process, okay, or whatever control process also can. Okay, this one already given. So this one already given the model, all right. But for this semester, it's okay if you have any idea to design any system, it's okay. You can also do another plan. It's not specific for this one. For example, for the group, maybe for the assignment 1, title 1 is the AUV yaw control. Okay, for number 2 will be ROV depth control. All right. So you can, the first step, okay, this one you have to run using the MATLAB. Okay, so because on the class I just cover on the MATLAB, but also you can use another techniques. Okay, another software. Okay, for example, we have the Qt Fuzzy Light. Okay, Fuzzy Tech, LabVIEW, and so on. All right. So normally for the class, for simplicity, you just use the MATLAB lah. Okay. And then the format will be given. All right, I already share the format on the group. Also, I give some example on the previous student. Okay, previous student. All right, so you have to submit for the both format the soft copy and hard copy. All right. So the first step, you have to design the PID. Okay, design the PID controller. Then you have to design the fuzzy logic controller lah. Okay, that's why you have to see here. So for this one, we have to use the MISO lah. That means 2 inputs, 1 output. Okay, just set to the MISO system. Okay, just 2 input and 1 output lah. Okay, this one you can use the Mamdani or you can use the Sugino. Okay, you can use the Mamdani or you can use the Sugino. Alright, and then you can design the 5 membership function. Alright, either you can use the triangular or you can use the trapezoidal. Okay, you can see this one. That means here 5 times 5. That means input 1 5, input 2 5. That means we have 25 rows lah. This one okay, we have here design at least. First step, maybe you can try 3 by 3 first. Then you can improve lah. You can improve to 5 by 5, 7 by 7, and so on. Okay, and then if you got the output is okay, then can accept lah. But normally it's not okay lah. The output is not okay, so that's why you have to tune your membership. Okay, you have to tune the fuzzy logic lah until the output will be you can get the good on the output response. Right. Okay, so this one before we show you what is the okay, this is MATLAB. All right, so I will Okay, I will show some. Okay, this one. Last. Okay, what is the difference between the Mamdani and Sugino? So this one I will share. But this one I already give the slide on the group, so you can see lah. So this one I want to explain what is the difference between the Mamdani and Sugino. So on the class we just focus on the Mamdani and Laksen. Okay. Alright. So this one for the MATLAB we have the Mamdani and Sugino. Okay. So this one I want to show you what is the difference between the Mamdani and Sugino. Alright. So you can see this one. The Sugino FIS, okay, FIS is the fuzzy inference incident, is similar to the Mamdani method in many respects. The first two parts of the fuzzy inference process, that means on the fuzzifying, the input and apply the fuzzy operator are exactly the same, okay, same with the Mamdani. But the main difference between the Mamdani and Sugino is that the outputs, okay, the output membership function. Okay, for the Sugino, output membership function is either linear or constant. Okay, linear or constant. That's it, the difference between the Mamdani and Sugino. Alright, so the difference is the output, only the output. The input will be same. Okay, before this we study on the Mamdani we do the 5 times 5, we have 5 input. Okay, the Sugino will be similar, but the output, okay, will be different. So the output for the Sugino will be linear or constant. Okay, for example, you can see this one, the rule for the Sugino. Okay, if input 1 is X, okay, and connection is N, input 2 is Y, then the output will be, we have the linear equation or we have the constant. Okay, is constant or linear. Okay, either linear or constant. That means we have some formula, either constant or formula. Okay, that's why you can put as the constant. All right. So this is okay. This is output for the membership for the Sugino. So you can see this one. The input will be same. Okay, the input 1, input 2 will be same, but the difference is the outputs. Okay, they put as the constant. You can put as the constant. So I will show some example. So this is some example, the output for the Sugino. They put some equation here. Okay, for example, you can see this one. Z equals to negative X plus Y plus 1. That is for output for rule number 1. Okay, rule number 2 is Y equals to negative Y plus 3, for example. Or normally we can set as the constant, or you can set like this. Z equal to 1, okay, Z equal to 0.5, Z equal to 0.3, okay, so that's it. It's you can say as the constant or equals to linear lah. It's okay. That is for Sugino. Okay, so this is advantages using the Sugino compared with Mamdani lah. You can see this one, a lot of advantages of Sugino lah compared with Mamdani. So the first one is that its computational efficient. Alright, it can be used to model any inference system in which the output membership function either linear or constant. Okay, it's work well with the linear techniques, for example like PID control. Okay, it's work well with optimization and additive techniques. It has guaranteed continuity of the output surface, and it's well suited to the mathematical analysis. Okay, that is the advantages of Sugino. Alright, so the advantages of Mamdani is intuitive. Okay, there's a widespread acceptance and is well suited to the human input. Okay, so this is the advantages for Sugino and Mamdani lah. You can see this one. So that's why based on your design you can use, for example, like the assignment before this. Some of students also can use the Sugino. Also, you can use the Mamdani. Alright, up to you. Okay, so this some example based on my previous student. Okay, this is for FYP. They use the Sugino. Alright, so the output will be on off. That means only 1 or 0. Okay, 1 or 0. You can see this one on this slide. So you can see the output off or on. Okay, on will be 1. Okay, on the 1, and then if off will be 0. Okay, that's why this is using the Sugino. Okay, Sugino. That means the Sugino, my student just said only, okay, this is output for valve. Okay, they open the valve. If open, that means will be 1. If off will be 0. Okay, for example, so you can see this one. On will be 1, 1, 1. Okay, if off will be 1. Okay, so this is input. Input will be same with before this. Okay, input will be same. All right, so we have 1, 2, 3, 4, 5. We have 5 membership function for input 1, and input 2 we have 5. Okay, also 1, 2, 3, 4, 5. 5 membership function for input. Okay, input 2, and then the output. You can see this one. We have 25 rows. Okay, 25 rows lah here. But the output we use the signal only on or off. Okay, that means 1 or 0 lah. Okay, that is for signal. Okay, so this is the example. Okay, example. Okay, so this is our transfer function. This is model that student use. Okay, they use the water tank system. Okay, so this is water tank system model. All right. Also, you can use this model to try your design the fuzzy logic. Either this student do the design is it correct or not. You can prove that is okay or not. Okay. So first, using you can check this one. First step, the student design the PID. Okay, you can see this one. The PID, we have the overshoot here. Okay, we have the overshoot, and then after design the fuzzy logic using the signal, so we don't have the overshoot. Okay, we don't have the overshoot, but this one you can see maybe overshoot we can improve, but the rise time will be longer compared than using the PID lah. But it's okay. The objective is this project is to overcome the overshoot. Okay, overcome the overshoot. That means will be objective will be successful lah, because we don't have the overshoot here. You can see no overshoot here. Okay, right. So okay, you can try this one, or you can try another one. This one I give this one paper I got from Google Scholar. So you can try this one. So this is the design of fuzzy logic PID controller, PD controller for the position control system. Okay, so this one you can see. So only give the some example here. Okay, the plan already give the transfer function, the plan for the position control. Okay, and then the first step they study about the PD, using the PD. Okay, next, okay, you can see this one. This paper, you can follow this paper, and then you can run. Is it okay or not? The summation design for fuzzy. All right, you can see this one. Also, I already shared to the group. Okay, this one some example. Okay, you can see this one, the membership inputs, input 1, input 2, and output. Okay, they use the 1, 2, 3, 4, 5. Okay, 5 membership function for input 1, input 2, and output. All right, you just follow this one. Okay, you try this one. After this, you can try this one, and then the rules here. Okay, the rule will be given here. Okay, the rule we have 25 rules. Just follow this one. Follow this one first, and then you can run. Okay, run here, and then check. Is it same or not? Okay, this one. That's why here not given. Okay, that's why maybe given on this one. Okay, so this one. Okay, right. So this state response of position control PD. Okay, this one. Okay, no. This one no output. No output for the fuzzy logic lah. That's why we don't know the performance of fuzzy logic. Is it okay or not? Okay, because on this paper we don't have the output for fuzzy logic lah. So this paper is lack on the outputs. Okay, on the output for fuzzy logic. That's why you can try this one. Because because this paper already give the input 1, okay, input 2, okay, for input 2, and also the output. Okay, and then also given the rule here. Just follow the rule, and then also another advantage of this paper also give the plan here, and then we can prove lah, is it this design of fuzzy logic is okay or not. Okay, you can try this one. You can try. So maybe next week we discuss about this one. So first you can try this one. Okay, design the input. Okay, the fuzzy logics. Okay, and then run. Check the output. Is it okay or not? Okay, for this paper, because this paper is not show the last output. Design the fuzzy logic. Okay, design the fuzzy logic. So it's not not appear the output here. So we don't know is it okay or not compared then using the fuzzy logic compared then PID or PD controller. Okay. Okay. you can try this one. So next week we can discuss about this one. Okay, at the same time we can choose the title for the assignment. Choose the apa? The model. Okay, choose the model lah. Okay, you can WhatsApp to me. Choose the model. Okay, and then your group members and choose which model you want. Okay, for example, you want to follow this model also. Okay, from 1 to 15. Okay, just give your name. Alright, WhatsApp to me your name, your members. Okay, and then okay, the model. For example, this one is the model number 1. You can check on the page. Okay, page 1 is the model number 1. Page 2 for model number 2. Okay, page 3 will be model number 3 lah. That's why you can see this one. I will put the name of the model. Okay, the thruster model depth control. This one ROV depth control, but it will be different ROV. So this one will be this ROV, and this one will be different ROV. That's why you can try. Okay, you can choose which one you want to design for fuzzy logic. Either you want to use, okay, for example, like model number 5 will be page number 5. Okay, so this is for underwater vehicle depth control. Normally this plan is based on the underwater robot lah. Okay, based on my previous study, on the PhD. So that's why also you can, that mention to you, also you can propose lah, propose for any model. For example, like this model. Okay, also you can use this model. Okay, water plant system. Okay, this is already gift for you, give to you for this one, for water plant system, or you can use this one. This one is we call the position control system. Okay, so you can choose. You can select lah. You can select your model. Okay, no need to follow this one. Okay, no need to follow. If you have another model, also you can design on fuzzy logic lah. Okay, alright. So any question? Okay, class. Okay, class. Alright. Okay, the due date lambat lagi. Due date for this assignment, I think before final. Don't worry, before final. Okay, so the due date for the assignment is before final lah. Before final. Alright, so that's why we have a lot of time. So you can find the if you not follow the model that I given to you, maybe you can find another model. It's okay, up to you. So you can find another model, but the assignment will be same. First, you have to design the PID, then you have to design the fuzzy lah. Okay, on theoretical that I mentioned to you, fuzzy better than PID. Alright, so you have to prove. Okay, you have to prove fuzzy better than PID. Alright, so that's the objective of our assignment lah. That's why you have to prove that fuzzy is better than fuzzy. Okay, there is no due date will be before final. Before final, it's okay. Okay, any question?
No, Doctor.
Alright, so if no question, I will stop here. So we'll be continue on next week. But at the same time, you can try. You can try run your MATLAB. Okay, try to design the fuzzy logic. The example I given to you. This one. Try this one. This one. Okay, this one. You can try this one using this model. Alright, using this model. Or you can try this one. Okay, based on my previous student. Okay, design the fuzzy logic controller for water tank system. Okay, using this one. Okay, so this you can try yourself. Okay, using your MATLAB, try this one. Okay, so either this one or this one. Okay, because the plan will be given here, the function will be given, and then this one first they do the PD controller, so you can change this one to the PID, right? Then you can design the fuzzy lah. Okay, so the input also will be given here, the input 1, input 2, and outputs, and then also the rules. Okay, so you can run the fuzzy logic lah. Then check the output. Okay, compare. You have to compare PID and the fuzzy. Okay, that mentioned to you on the theoretical, you have to prove lah. So on the theoretical, fuzzy better than PID. So that's why you have to prove that on your assignment, fuzzy is better than PID. Alright, so that's all for our assignment lah. For our assignment is to prove that fuzzy is better than PID. Okay, that means fuzzy is better than conventional controller lah, the PID. Alright, so if no question, I will stop here. Alright, so at the same time, okay, you can try, okay, using your MATLAB, okay, try at home, okay, how to run the fuzzy logic using the MATLAB. Okay, also you can watch this video after this. I will try to upload to YouTube. Also you can Google lah. You can Google. Also you can a lot of YouTube. You can see the how to design the fuzzy logics. Okay, using the MATLAB. Okay, the step also given on the YouTube. Alright. So if no question, I will stop here. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Wow,
Thank you very much, Doctor.
Okay, welcome.
Thank you, Doctor.